Okay, so this is Energy 101, fall 2015, and it's the first lecture. And I thought what we'd do is we're not going to start in the conventional way. So I'm just going to start you right off the bat with an engineering, math, environmental problem, just something to get the brain cells firing here. And then in the second third, we'll go over the syllabus, and then in the last third, we'll kind of just open up for our discussion, introductions and all that. So here's what I want to do. I'm first going to, and I'll give this problem in two separate parts. The first one's pretty easy and straightforward, just a little bit of arithmetic. And then the second one, I'll make an analogy between another problem and let you work your way through it and solve it. And then after you've struggled with it a little bit, I'll show the solution, or at least the one I came up with. So here's what I want you to do. So the first part is, and I'm going to call this the birthday problem. Sometimes I call it the inheritance problem. But here's the deal. So you're going to get $1 per minute from a rich uncle and relative. Someone's going to give you $1 a minute from the day you're born. And what I want you to do first is figure out, and we'll just do this individually first so you could work on your own. I want you to figure out how many dollars you will have on your 100th birthday. So just, minutes per day, days per year, and then we're going up to 100 years. So dollar per minute. So the question is, how much money do you have on 100th birthday? And I'm going to just blank the screen so you're not looking at my scratches while you sat. I'll do my own little calculations so you can see how I work through it. And don't, if you can't get the exact number, just use a little bit of rounding. And so if you don't, I'm going to have a calculator, but I'm just going to run it here. So I'm going to do $1 a minute, yeah. Which one?
In this problem.
What's the variable?
Leap years.
Yeah, a little bit. Yeah.
Depending on when you're born, depends on how many leap years there are. in that 100 years.
That's true. How would you, there's two ways to address that.
I just thought of the way to address it.
Yeah.
Well, it's, yeah, all right, yeah. Okay.
There's a couple ways. I mean, you
I
could
got
take
you.
the, average days per year, or,
I got you.
yeah. Was there, did we skip a leap year in 2000? Am I remembering that right? Because once in a while, the leap year days overcorrect, and then you gotta
Yeah, because I
knock
think they
one
go by
out.
like, what, 365 and a quarter a year, but it's not actually
Yeah.
an exact quarter.
Yeah, it's like, it's a little less than a quarter, so the leap day is an overestimate, you're right. Everybody got an answer, though? Something close?
I just realized something I left out. I was figuring it in,
Okay,
but go ahead.
okay, all right. All right, so here's what I came up with. And the way I've written this, I wish Rain were still here so I could pick on him a little bit. I'll show you how I wrote this up. So what I gave you initially was $1 per minute. So the $1 is in the numerator, the minute is in the denominator. And then we know that there are 60 minutes per hour. So, rather than use the parentheses and the multiplication and all that, that's all implied in what I've written. I've just used, one giant division sign here. Each one of these spaces, each one of these vertical lines just partitions each number, and multiplication is implied across the top and across the bottom, and obviously division, anything on the bottom is divided into whatever there is in the top. So I just started with $1 a minute. I know that there's 60 minutes in an hour. I know there's 24 hours in a day. I know there's 365-ish days in a year. And then I just multiplied this by 100 years. And I'll go ahead and put the units on here. And now is actually a great time to discuss a little bit units and numbers. So in this little math problem, we've got units. Dollars are units. Minutes are units of time. Hours are also units of time. Days are units of time. Minutes, obviously. Hour, there's days there, there's a year, and then year. Everything else, the number 1, the number 60, the number 24, the number 365, and the number 100, those are all numbers. So you multiply those together, and that's just arithmetic. So I'll just do that together. So I've got 1 times 60 times 24 times 365 times 100 equals, we come in at 5,256,000. Oh, sorry, 52,560,000. So we'll write that down there, keep track of commas, and that's the number. Now, pretty easy. But let's go back and double check to make sure that we got the units crossed off correctly. And I'll guarantee you that you're going to see this a bunch in this class, looking at the difference between the numbers that are out there and the units. So let's go back and let me pick another color here. Now what the heck, that's fine. So I'll cross minutes off with minutes. I'll cross hours off with hours. I'll cross days off with days, and I'll cross years off with years. The only thing that survives there is the dollar, right? The dollar. So kind of trivial, but I've kept track of my units, and I know at the end, all the other units cancel. The only thing I'm left with is $52 million. Right? Sounds about right. Okay. So 100-year-old person is a 52 million minute old person. All right, now the next question, so I'm going to ask you to do, and Tim, the smoke, you said the fire extinguisher somewhere? So-
Yeah.
Okay.
It's right here, by the door.
So here's what I want you to do. I want you to tell me when you get to retire, but instead of dollars going into your bank, you're going to put carbon bonds into your energy system. So you can think of having, instead of a rich uncle giving you money, you can think of Uncle Helios, the sun, giving our planet photons so that carbon bonds can form through photosynthesis, right? Coal, oil, natural gas, your fossil fuels. So what I want you to do is estimate how long ago that bank account started. When did the Uncle Helios bank account take its first deposit? So you're going to put that in years. And then I'm going to tell you that humanity started taking withdrawals from that bank about 150 years ago. So in your textbook here, we're going to get into Titusville, Pennsylvania, 1860. That's when the first major oil discovery was made on this continent. And yeah, there was some coal being mined before that. But with the Titusville discovery, that more or less launched our fossil fuel boom that we're in the middle of. So we'll just state that 150 years ago, we started taking withdrawals from that bank, and we're just going to work under the assumption that we've used about half of what's in there. So I need you to tell me how old that 100-year-old person is when he or she retires. So you're going to compare what our carbon bank looks like compared to an actual bank account. So you're going to take those years and compare them to minutes. So in the first problem we did everything in minutes. In this problem we're going to do it in years, and you just have to make that comparison. So I'll let you digest that for a while, and then I'll show you the answer. And why don't you guys work in teams, actually? Normally we just do this in teams, so David and Todd, sorry, I didn't catch your name. Joseph.
Tynan.
What is it?
Tynan.
Tynan. Joseph and Tynan, you guys can tag team.
No. All you gave us was 150 years.
Yeah, and halfway.
Okay.
Yep.
You didn't give us any other amounts in there.
No, you're going to have, I asked you to try to decide how long ago that bank account was open, and it was more than 150 years ago that the sun started, the living organisms started banking carbon for us. You can, just take a reasonable guess. I would use a scientific one rather than a biblical one.
Complete loss,
Yeah,
to be honest.
yeah.
You're saying, all right, 150 years ago is when it started, over 150 years ago.
Oh,
3 billion
well,
years ago.
yeah, I mean, there's the planet, by most estimates, the planet's somewhere between 4.5 and 3.8 billion years old. And at some point, relatively early, life started on planet Earth. Photosynthesis, bugs, green things, stuff swimming in the ocean. So, take a shot at how many years ago that was. And that in that time span is basically going to be equivalent to your 100-year lifespan. So that's kind of your,
So you're saying, what's that?
How's it go? Yeah. What's the deepest thing in the Grand Canyon?
I think it's 2 billion.
Okay. Yeah.
That oldest rock.
Oldest rock, yeah, yeah.
Fish and shit.
So you're
I'll
gonna,
give you a hint, though, to start this off on any problem. Write down what you know.
Yeah. There you go.
Gotta write down what you know. You can't find what you don't know if you don't know what you know.
Are we retiring in 65 years?
You gotta find out when you retire. I mean, you could make that assumption and check to see if it's right based on the other information I gave you. And if all else fails, by the end of 5 minutes, you can make a guess.
2 billion years ago.
2 billion years? Yep. Put that over 100? Over 100? Or under, I don't know. I guess it doesn't matter.
Yeah.
Because that's your end for both of them, right? Your time span, 100 years and 2 billion years, if that's what your end is.
So those would be.
That's when we started using it.
Okay, so now you're saying he's giving us 150. So basically, we need to find out what percentage or what fraction of 2 billion, if that's what we're using, is 150 years, right? That's what he said we started,
Oh.
burning up the ozone, essentially with fossil fuels.
What we don't know, What's the question?
I guess that's a positive note. 3 years later, it seems a lot easier.
Yeah, good.
Don't we need to know how much we want to retire on?
Oh, you're gonna spend it all.
Oh, you got to.
Oh, yeah, you're gonna spend it all, yeah.
Before you retire,
Yeah, you're gonna come out even.
so retire at 62?
Well,
But it's spending at a set rate, not randomly of, $1 million here, $1 million there.
yeah. I'll let you struggle for a couple more minutes, then we'll.
Which is weird. Who's my smartphone?
That's what I'm doing.
Oh, no, this was not complicated.
Yeah, it's usually just spending some time with it.
One of the coolest apps on this thing. Can you play with any of the apps on those, Brad? You got the mechanical engineering toolbox.
Oh, really?
That's like all the,
That's after 100 years we started.
whatever you want to do,
Oh, wow.
click on any one of them.
Shit, man. Choose a material, is there, oh, I see, wow, look at that. Was this a free download?
Yeah.
So 100 starts here. And live out until we're 100.
It's like every nifty thing. There's unit conversions. There's a fraction calculator because I'm lazy.
Nice.
I'd rather, well, I use it for woodworking.
So we could figure out how much one to do that.
Mechanical, and this, and so this is just a,
This is free app download.
We know how much you had. divide by
There's
the-
one
that's
for
cool.
unit conversions.
You know, so you could spend this much per day.
I'll tell you what each one is.
For the next
Sweet,
35
man.
years until you're 100 years old.
pipe size.
But even then, at 65, you're still accruing.
It's the one that tells you weight
Pipe
and
size.
everything.
You had X amount at 65 to start spending, but also every day you accrue X amount too, because you're still earning till you're 100. But
I've got another one somewhere that tells you like, for different kinds of standard size steel,
Mm,
it tells you what each, like how much it weighs per foot,
you still
Nice.
don't have
which is kind of critical.
information to tell you, hey, this is when you need to, where you need to start.
I found more nifty stuff on that.
shit, and I like the beam load calculator, look at that. Ooh, that's tight.
Useful.
Yeah. Get to quit using my brain entirely, that's great.
But there's no birthday equation in there.
No.
That's what I found is like really useful,
I
because
like
you have
that.
to know the stuff.
Well,
first.
yeah, sure, exactly. Yeah, it's like, okay, I've got a Chinese to Portuguese converter, but that's not gonna do me much good.
2 billion or
There's a calculator that even does our crazy math with Greek symbols.
Oh, nice.
you know, say 3 million instead,
It's
throw
unit
a
converters,
fraction of 150 years on that.
the one that doesn't,
Significant.
the one that I tease Cheryl with, the thermal camera, and she's all excited. She's like, "I've got a thermal camera on my phone." No, not really.
Does it just do a little,
Did you say 2 million?
it just converts from one,
Okay.
yeah, oh, it looks like, yeah, it's just do a little
Mm.
algorithm.
Cheryl's like, "How's come your ice cold beer is the same temperature as your shirt?"
Okay, so,
Because I'm cool.
okay, so 150 divided by 2 billion.
So there was an advantage to AT&T buying
7.5.
out DirecTV. We got new phones. you get
Oh, really?
50% off
Oh,
from AT&T.
So
So
that
we got
would be
new
Pro-
phones with a full service plan
1, 2,
for less than what we were paying a month.
5.
for all employees? Wow.
Yeah, you gotta get Shanta over in that direction.
Yeah, man,
So that's.
I don't think she'd wanna sit on the phone talking to people all day.
well, she's done a lot of that in the past, but,
Over.
she's actually got some interviews in Michigan, and,
So that gives you.
yeah, I'm not exactly sure how it's gonna work out with the kids and the house and everything. It's a little, she's just been trying her
Of the lifespan.
butt off to find something here in town. We'll see.
Is that.
There's just not, unless you're going to UM, there's just not much for.
I know, yeah. There's a new
So.
osteopathic medicine center that might open here. They're weighing in, I think there's good bone and joint services here in town, but in terms of education,
Figuring out.
I don't think there's a training program, but if that opened, that'd be a great fit for her skills. We'll see.
All right, so.
I thought that was around the award ceremony last
What's
week.
that?
The governor said that this,
Right, so
either the governor or the mayor said that this
We're
is the number
paralleling.
one growing
Up until
State
150 years.
For new
ago,
businesses?
for new businesses.
Yeah.
It's like,
Well, yeah. Everything up
everywhere
until
except
70.
Missoula, because it's
So-
difficult here.
I wonder if they're measuring that as like,
I know.
let's just say there's 100 businesses here already, and you add 10 more, you got 10% growth, or, because, I wonder if it's like a percentage thing instead, I don't know.
Years is the same as your other
Because I
35.
looked into it, and it's like, you know what, it would be easier to just.
So now you're trying to
under the
figure
table
out-
than it would be to start a business here.
Will you
Because of
be able
taxes
to
and permits.
Yeah.
make it to 100,
You guys suffered enough?
even though you've already,
I think we've suffered and came up with an answer, but I
Okay.
don't.
Okay. How about you guys? Finished suffering?
Sure.
Okay.
I'm bloody.
What I'd like to do first is just take either the number you got or an estimate. So back, what do you,
Didn't get anything.
all right, well, I gotta get something, so give me an estimate. When do you get to retire?
didn't come up with anything.
When do you think you might get to, if you had to guess, being either optimistic or pessimistic?
It was a.
At 65.
65, okay, that sounds pretty optimistic. All right, and then how about over here? Okay.
That's unanimous.
All right, let's see, all right, go. So here's how I would go about it. So in the first case, well, let's look and see how, would you guys come up with sort of as an origin of life number? 2 billion, 2 billion, okay. I'm just gonna, this is just for the sake of argument and ease, it's not gonna affect the final answer a whole heck of a lot, just because the numbers end up being pretty small. I'm just gonna say 3 billion. I was just over in Colstrip last week, and the guys over there would say, well, no, most of that coal is 150 million, 65 million years, et cetera, et cetera. I'm like, okay, fine. And Tim was saying a second ago, we're going to assume that the rate of deposition was constant. It's not. There's going to be the Carboniferous era and all that, where there was more carbon put in the bank than others. But we'll just make the assumption that it was sort of constant. Now let's look at that 1865 deal. 1865, and here we are in 2015, and we'll get into what a bell curve is later, but for now, let's just draw this as a triangle, as a triangular wave, and say that if we're at the peak of fossil fuel extraction right now, meaning that we've taken about half of it out of the ground, and we're taking it out of the ground as fast as anybody ever has in history. I don't think we're going to be able to argue about that. So you start out here, kind of slowly build up. Here we are at the peak. Now, when does the tail happen? If we're halfway through, it's symmetric. Okay, so what year in the future?
Well, that's
2165.
that's predicting a constant being able to pull it
Yeah,
off the ground.
that's all it is. It's an oversimplification, but yeah, 2165. 300 years in the 150 years from now, 300-year total. So that's the that's this guy. So here's 300 years. I'm doing this a little bit out of order, but that's okay. 300 years. Let's make sure our units are consistent. Years. Now, how old was that 100-year-old person? How many minutes?
52,560,000.
Yeah, so I'm going to just do a little engineering massage on that and get rid of some of the extra numbers. So 50 million. Okay, minutes, right? Okay, so what number goes right here? How many minutes goes in that little denominator? At 3 billion in this basement, 300 in that attic, 50 million over here. I can cross off a couple 0, 0, 0. If we do something like this, we can sort of put our 1, 2, 3. 1, 2, 3. So now we're looking at 3 over 30 million. What's that going to equal over here?
Lots of zeros.
Well, it is X. Thank you. It is X. What does X equal?
3 times 50 million divided by.
I mean, I could. Sorry to interrupt. But I could even do it this way. Just say there's a 1, and there's a 1. So I'll even rewrite it. So I got 1 over and I'll get rid of the years too. I got 1 over 10 million equals X over 50 million. I haven't done anything with the units yet, so I'll just keep the minutes there.
Five, 10.
Make it 5, right?
Yeah. Better be 5. Yeah. And if, if we wanted to do it out, if we wanted to just take it one step further, let's go ahead and run the rest of it. Courses 101. Birthday problem. Just so we use all of our math skills here, we'll say that 10 million X equals, so I'm gonna multiply both sides by 10 million. I'm also gonna multiply both sides by 50 million minutes. All right, so right away, I can just say that X equals 50 million minutes divided by 10 million. Right, so well, the entire 10 million gets absorbed into the 50 million, and we end up with X equals 5 minutes. So 65 was a little bit optimistic. So what does this mean? Well, it means that when we look at the history of the planet and we look at humankind's recent arrival on the scene of organisms, and we look at our relatively or absolutely, or I don't know, there's only been one Earth ever, so we don't have anything to compare it to. But we look at the rate at which our technology has been able to access fossil fuels. We see that we are right here in this little 5-minute carbon-fueled party. We're halfway through it, and something's got to give, right? So I think that's why now, in our lifetimes, we're starting to see more renewable energies come online, and for a variety of reasons. Some is because the deeper you have to dig for these things, the more expensive it becomes. The longer you develop a technology like wind turbines, like PV, the cheaper they become. And right now we're kind of at the point where economically a lot of the renewable energy technologies are competitive with the fossil fuels. We're also at a special time in that it looks like all of the free lunches that we've been getting from burning fossil fuels are coming back. We've sort of seen what the data has shown us in terms of increases in mean surface temperature. I don't know if you saw the whole inconvenient truth thing or whatever, but it's kind of hard to argue with the fact that, yeah, when you set things on fire, the place gets hotter. And that's why, that was one of the main reasons why I got into energy technology in the first place, just so I could understand the gravity of some of these problems that we're facing, and to put them, into a deep historical perspective, but then also really more into the perspective that we're going to talk about in this course. So we're going to We'll come up through some of how the ancient Chinese, the ancient Romans used energy. We'll look at trajectories in oil, coal, we'll look at nuclear, we'll look at natural gas, really all of the so-called conventional energies. So and I think once we get a good grasp on that, we'll be able to move into the material in 102 and see what place the renewables are likely to play in the energy future. So doing this problem, just for me, seeing these big numbers and realizing we're a very special place in history was enough motivation for me to get into this field. Okay, does that make sense though? How we did that problem? You're like, oh man, we're pretty close to the end here. We in terms of our energy supply. So okay, well I'll take a little pause. Oh, and I also want to mention that these recordings, I'm just going to do 3 recordings of 15 to 30 minutes. This one went a little bit longer because I had you all working in groups there. And there'll be about 3 recordings per lecture. So hour-and-a-half lecture, 25, 30 minutes per. We'll have 6 per week, 6 times 15. What's that? 60, 90 little segments by the time the semester's over. Okay. And these will all be available little links to YouTube within the Moodle shell.